Hello, everybody. Hopefully you can hear me. Hopefully everything's set up. I'm kind of in a rush this morning, setting things up a little bit. I'm 3 minutes late. I thought I was going to be 5. So, that's good, right? I noticed in the comments that there were some people that were upset by my title, saying that it's not fair for me to say that creationists lie when, most people lie from time to time. Well, we're going to be looking into that. We're going to be looking into how it is specifically that creationists have been lying with numbers, using math to tell lies. But I'm also going to point out how common this is, how ubiquitous this is, and also how not only do we lie with math, do we lie with numbers, but we accidentally deceive ourselves. And it is kind of hard when you're looking at someone who's deceiving their audience with numbers. It's kind of hard to tell if they've deceived themselves as well, or if they're actually deliberately lying. So for those that are upset with me for saying that creationists are lying with numbers, I suppose you could make the argument that, we can't say for sure that they're lying unless we actually know the intents and, things inside their brains. And that's fair. But false truths are often communicated with math. And there's a lot of reasons that this works so well, or that this happens so often. First off, everybody trusts math. All of us who have learned how math works, we know that 2 + 2 = 4, and we know that you can't change that fact. It's a mathematical fact, and it can't be changed. And so when we have numbers that back up the claims that we make, this gives our claim a really solid sense of authority, a really solid sense of truthfulness. And because of that, you see people use numbers in arguments all the time, from issues on politics. If you're arguing gun violence, for example, maybe you're pro-gun, maybe you're anti-gun, you're going to look for numbers that support your position, and you're going to use those. We have in the news this with Donald Trump, the alternative facts, this idea. And alternative facts are usually based on using different number sets to make an argument. So your numbers can actually be correct. They can be accurate, but you're using a very specific number set that's different than your opponent. And so your facts, the facts that you're using, are alternative facts to those used by your opponent. So this was something that when it was first brought up in the campaign, I can't remember if it was Donald Trump himself or one of his campaign people that first put forth this alternative facts type thing. But we all laughed at it like, you're an idiot. There's no such thing as alternative facts. But actually, if you look at the way that people use numbers to make arguments, you'll find that you could say that there are alternative facts. There are, especially any complex issue, you can look at specific sets of facts and leave others out, often called cherry picking, to come to one conclusion, and you can do the other on the opposite side of the argument. And this is how most arguments in politics happen when they're using numbers. Is they're cherry picking the data, and this cherry picking numbers is one way in which we can lie with math, but the other way that people can lie with math is by simply doing story problems wrong. Usually, if you screw up on your actual math, people will call you out on it. But if you screw up on the story problem, most people won't notice, because we suck at doing story problems. So I've got some slides prepared to talk about two big lies that are often put forth in the creationist movement that involve numbers, involve math. So let me just share my screen here. We're going to see infinite screen for a second. All right. Hopefully you can all see my slides now. So, how creationists lie with math, and indeed how most people lie with math. I want to point out that all of us, I guarantee that you currently believe something that's false because you got tricked by some weird math. I'm sure that I currently believe something that's false because I got tricked by weird math. And maybe the person that tricked me did it on purpose, or maybe they were actually tricked with the numbers as well. So this is extremely common. It's not just creationists that do this. here are two big claims. Math shows it is impossible for protein to form randomly, therefore the origin of life is impossible. This is a super common claim. It's in videos all over the internet. It's in multiple books, especially popularized by the intelligent design community. They've got a bunch of stuff on this. And then the second claim is that math shows that the fossil record is nearly complete. Therefore, all gaps that we find in the fossil record show created kinds. They are evidence for creation. So gaps in the fossil record are evidence for creation because math shows us that the fossil record is nearly complete. So I'm going to, just to make sure real quick that everyone's hearing me, I'm going to go through the comments here. Sorry, you're now looking at my infinite screens. Looks like all is well. Everyone's able to hear me and stuff. Okay, back to my slides. So these are those two claims that we're going to be looking at. But again, alternative facts are found everywhere. I was looking at just arguments in Facebook just yesterday to kind of look for examples of people that are doing this, that are using math to lie to each other. And I saw an argument between a vegan and a meat eater. And, the vegan argument is that by eating a plant-based diet, you're being nicer to animals. That's one of the arguments for being vegan. There's a bunch of other arguments for being vegan as well. Just so you know my personal stance on it, I think that, I am an omnivore. I eat meat from time to time. I eat much less now than I used to, but I do believe that vegans are, in general, correct. Eating less meat or even eating no meat, if you look at the data, it really is better for the environment. It's typically better for the person, unless they have certain metabolic issues, in which case some people actually do need to eat meat. And in general, it's far better for the environment in general to eat a vegan diet than to eat a omnivorous, or now there's the new popular carnivorous diet that's coming out. But the argument that I saw being made on Facebook was that one loaf of bread kills roughly one mouse. 1 pound of beef only kills 1/1200th of a cow. And they based these numbers off of this article right here called "Ordering the Vegetarian Meal. There's More Animal Blood on Your Hands." And this is an article that breaks down the numbers of how many mice are killed when wheat is being harvested, and then how many mice and rats are killed later to protect grain when it's being stored in grain silos before it's made into products that go to stores. And if you do the math, well, based on the numbers in this article, it is about one mouse that dies per loaf of bread that is made. And so you could say, the sentient being known as a mouse is equally as important. It can suffer just as much as a cow. Therefore, eating bread is worse than eating beef. Well, the convenient fact that's left out in this equation is that most beef, especially beef in America, is grain-fed. And if you use those exact same numbers that were used in that article, producing 1 pound of beef kills 13 mice, and then more rats are killed in the slaughterhouse because and these numbers are not included in the article, and so I don't know what they would actually be, but slaughterhouses have to kill rats because rats love eating meat. And so you're slaughtering 13 mice per pound of beef produced because of all the grain that's required to feed the cattle. And then you're killing an unknown number of rats as well in the slaughterhouse, and then in the places that store beef and so on before it's sold. And then this number right here that 1 pound of beef only kills 1/1200th of a cow. That's assuming that every pound of a cow equals meat. That's not true. There's only about 480 pounds of beef in a 1,200 pound cow. So you can see that the math here is completely screwed up. And if you're living on bread instead of meat, especially the way that meat is produced in America, you are dramatically more kind to wildlife than if you eat beef instead. So this is one way that people are lying with math. And the really interesting thing about this is that if you feel guilty for hurting animals, when you see this math showing that bread is more deadly than cows, you don't want to question it because it tells you what you already want to hear. It eases your pain. Like, oh, I'm not such a monster. I'm saving the lives of mice, right? So there's this. You see this in arguments on politics all the time. You see this. We always want to agree with the numbers that support our pre-existing beliefs. We are horrible at looking at things, from a neutral perspective. So that's one of the really common examples. Well, not a really common example. An example I found just in my Facebook feed the other day when I was looking at this, arguing for eating meat. And then another example that I found was that, I just moved to Canada, and Canada just legalized marijuana, and I'm seeing a lot of people arguing about, should everybody legalize marijuana? And there was a study, I believe it was 2017. Well, hold on, here it is, 2016, saying that the continuity of cannabis use and violent offending over the life course. That's a really weird title. But what the paper is saying is that long-term marijuana use is linked to violence among people studied in England. And this is a really interesting study because it was over a 50-year period where they followed these people, and they found that people who consistently smoke marijuana end up committing violent crimes. They're far more likely to commit violent crimes as adults after 20 to 30 years of consistent marijuana use. And the people who wrote this paper said, look, marijuana is causing violence. But this is so hilarious because to anyone that knows anything about the black market and how it works, in England, marijuana is illegal. And so if you want to buy marijuana and use it in England, you have to buy it from a drug dealer who is working in the black market. And if you are a drug dealer working in the black market, guess what? If you get robbed, if your client robs you, if another drug dealer robs you, you cannot go to the police. You cannot file a report. You have no power to get the state's help if you are injured or robbed. And because of that, everybody who works in the black market has to be tough. They have to project. They either have to be violent or they have to project that they could be violent if need be. They have to intimidate people into not robbing them. That's the only way for them to defend themselves. The rest of us, when we work in a normal legal job, the threat of police violence or going to prison is what stops people from screwing us over and stealing from us in a normal day-to-day situation. But if you work in the black market, you have to be aggressive. And so if you are smoking marijuana in England your whole life, you are dealing on a regular basis with either a violent criminal or a criminal that pretends to be violent. And that's going to rub off on you. That's going to affect the way that you behave. You're constantly interacting with these people, and they might even be threatening to you from time to time. And it just makes sense that that alone could be the actual cause for this slight increase in violence among pot users in England. And that was not controlled for in the study. And it's really funny because if you look at interviews of the researchers that did the study, they're saying we controlled for every relevant thing. We controlled for socioeconomic class and so on and so forth. But when you look at the paper, they did not control for the fact that, people who buy marijuana are doing so illegally and therefore have to deal with violence on a regular basis. This study, in order to be accurate, would have to be done in a country where marijuana is legal and has been legal throughout the course of the study. Until I get data like that, I'm going to say that this is lying with math. We need data that controls for, this situation that I just put forth. So lying with math is super common. It's not just creationists that do that, and it's not just the uneducated people that do it. These are top-notch researchers that are lying with math on accident. I don't think that they're trying to lie with math, but they've made mistakes. They've fooled themselves into believing something that's might be false. It might be true. Maybe long-term cannabis use does lead to violence, but their research can't really prove a causal link there. So, okay, so now we get to the creationist claims here. This is one from the book, The Nature of Nature by William Dembski. And William Dembski is one of the big guys in the intelligent design community. And in his book, he says that the chance of building a single functional protein of 150 amino acids from scratch by chance is 10 to the power of 164. So that's your chances of doing it. If you just keep on randomly creating new sequences of amino acids, you're going to have to do that 10 to the power of 164 before you get a functional protein. And this is based on math done by real researchers that were doing life origins research in the past. And these types of calculations were important for us to figure out, when we're studying the origin of life, some things happen by chance, some things evolve through descent with modification, acted upon by selection. Some things are directed by natural selection in some way or another. And what sorts of things would it be reasonable for us to assume happened by chance, and what sorts of things would have to have happened under direction of natural selection? And this really helps us, piece together our thoughts and try and solve this really crazy puzzle of how did life on Earth emerge. And by the way, this is not a solved puzzle. We're still working on this. And so these types of calculations were really important earlier on. And a bunch of issues around these have been solved, but the intelligent design people don't want you to know that. They're hiding all of the solutions that have been solved to this. But then, William Dembski goes on to say, to put this number in perspective, there are 10 to the power of 65 atoms in the galaxy. And so when you realize that for us to expect that functional proteins came about from scratch by chance, this is a ridiculously stupid thing to believe, right? Like that can't happen. A functional protein of 150 amino acids is not going to emerge and have function. So we need another explanation for the origin of long amino acid sequences. And this claim is repeated over and over and over again in videos like this. This is a video on YouTube called Origin, Probability of a Single Protein Forming by Chance. And it goes on to say that because this math is true, and this math is true, these numbers are accurate. And I'll show you what they're based on here in a second. Because that math is correct, those equations are correct, the origin of life is completely impossible. Let's see. Did I add the slide that shows you? Oh, I missed that. I forgot to add the slide that explains. Oh no, sorry. This is it. So this is the slide that shows the three different probability equations that are added together to make that that big probability number. So this number of 10 to the power of 164, that comes from these three different issues in the origin of proteins. The chance of making 150 amino acid sequence with only peptide bonds is 10 to the power of 45. I wonder if I should explain to you what that even means. Basically, for those that don't know, a protein, which is a functional unit inside of a cell. Proteins in modern cells are pretty big. They're typically between 150 amino acids long. They're made out of amino acids. A protein is made of amino acids. It's a chain of amino acids. And the smaller proteins in our body are about 150 amino acids long. The larger ones can be, they can be thousands of amino acids long. And these chains form through peptide bonds. And if you have two amino acids, they can actually bond to each other in multiple different ways. One of those bond types is a peptide bond. And so the chance of getting 150 amino acids to bond with each other, all using a peptide bond, is extremely rare. So that alone is difficult. Then the chance of using only left-handed amino acids. You can have left-handed amino acids and right-handed amino acids for most of the 20 amino acids used in life. But living cells only use left-handed amino acids. They never use right-handed amino acids. So the chances of doing that, because you've got two options, is 10 to the power of 45. It's actually, that number is actually a little bit wrong, because not all amino acids have chirality. But anyway, it's pretty close. Oops. And then the chance, sorry, my slides are freaking out. And then the chance of making a stably folded protein, 150 amino acids long, is 10 to the power of 75. So yeah, you put those all together and you get this number of 10 to the power of 164. So that last number, most protein sequences are not stable in water. They will not fold properly, and they will they'll float to the surface, or sometimes they'll sink to the bottom of a liquid that they're floating in. And so amino acid or proteins need to fold in order to be active inside of a cell. And there's other reasons why proteins need to fold. So he's saying that if you want a protein that's 150 amino acids long, the chance of getting it to fold just by random chance is 10 to the power of 75. You add all these together, it's a ridiculously improbable number. Well, every single one of these issues has already been well studied by scientists studying the origin of life, and we already have solutions to all of these weird problems. So we know, for example, how abiotic systems can sort molecules by chirality, by left-handedness or right-handedness. We already know. There's extensive literature, and you can read an overview of it here in this article. We already know how normal natural systems can sort molecules by chirality. So this is already a solved problem. We don't know exactly how it happened in the origin of life, but we know many ways in which it could have happened in the origin of life. And so this middle number here, the chance of left-handed amino acids, that is completely irrelevant to the origin of proteins. Furthermore, we don't even believe that proteins were the first functional molecules in life. A bulk of the evidence shows us that the first functional molecules in life were chains of RNA or chains of a chemical similar to RNA. And this is one of many papers that talks about this. This paper talks about the ancestral ribosome. The ancestral ribosome was a pure RNA-based functional molecule. And what it did is it actually took amino acids in its surrounding and it stuck them together using peptide bonds. That was what the function of the ancestral ribosome was. And so this paper actually knocks out these other two, or this first number here. So the chance of amino acid sequences coming together in peptide bonds, well, if you've already got a ribosome, a primitive ribosome, it's already doing that. It's solving that problem for us. So that first number is irrelevant. And then, yeah, it's ribosomes form much easier than functional ribosomes form, functional ribozymes, so functional molecules made of RNA, form much easier in prebiotic experiments than functional proteins do, because they don't require the really complex folding in order for things to be functional. A chain of RNA will actually fold simply based on its base pairing with itself. And to learn more about that, I have this video called "What is the RNA World Hypothesis?" and it shows you how different RNA chains can form and how they can fold into complex three-dimensional structures and how those can have function. So take a look at that video. What is the RNA world hypothesis, if you want more information on that. This paper, The Origin, Evolution, and Structure of the Protein World, this talks a lot about protein folding and other issues and how different prebiotic environments would have solved these problems. Instead of creating a 150 nucleotide long peptide, 150 nucleotide long, sorry, wow, my brain this morning. I'm sorry, folks, I did not have coffee. The 150 long amino acid protein. There's, in the origin of life, we had these really small proteins with maybe just one fold in them, and these can grow. Here's a paper talking about how these small proteins can grow through combination with other small folded proteins, so that you don't need to start with 150 amino acid long protein that can fold. You can start with much smaller proteins, and the probability of these emerging by chance is extremely high compared to those numbers that the creationists are using. And here's another paper. Again, you can look up all of these papers, read them, and you'll understand that everything that these creationists are doing, this statement that the chance of building a single functional protein of 150 amino acids from scratch by chance is 10 to the power of 164. This is an example of people failing to accurately do story problems. They are neglecting all of the data that we have. They are neglecting the actual theories that we actually have about the origin of life. They are creating a straw man theory that we actually think that functional proteins had to emerge from scratch that are at least 150 amino acids long. That's the straw man theory that they're attacking. Their math is correct, but everything about their claim, everything else about it is absolutely false. So there we have it. I'm going to go to questions real quick to see if we have any. Shannon asked, will there be links to those papers in the description later? Yes, I'll do that. I just was running late and didn't have time to put them in here. Let's see. Any other questions that have been directly sent to me on this protein folding issue? A lot of people are talking about marijuana and violence. What do cows like to eat when they're high? This is what I get for talking about marijuana and meat in the start of my presentation. Ration All Mind says, proteins don't have to be stably folded to be functional. Intrinsically disordered proteins can also be functional. Yeah, that is true. But in the study of the origin of proteins, we do care quite a bit about protein folding because it seems to have happened really early on. If you look at the ribosome, so the ribosome is this giant, it's one of the few molecular machines in our bodies that's still just made of RNA for the most part. All of its functional bits are made of RNA. And we can actually look at the ribosome and find which parts of it are most ancient. At least there's good reason to think that we're able to actually parse out which parts of it are most ancient. And it's really interesting because the ribosome, all of its functional bits are made of RNA. So this, which gives credence to the RNA world hypothesis, right? But it's stabilized by little microproteins. And actually modern RNAs have pretty complex proteins also added to them. Really complex proteins in some cases. But when we look at the really ancient parts of the ribosome, the proteins that are in there, they're not folded proteins. They're really small proteins that simply attach to the ribosome and allow it to stabilize itself. Excuse me. They allow it to be stable. And so we think that a lot of the early functional proteins simply, they weren't functional on their own. They only were functional, and they were stable because they were bound to chains of RNA and other molecules in their environment. So that is true. We don't need folded proteins, nice, stable folded proteins, in order to get function. There's lots of different ways to get functional proteins. And again, when we look at the ribosome, it seems like the early proteins that existed in life were not folded. So, and they were also very small. They weren't 150 amino acids long. So, Shelled Reptile says, do scientists know how RNA rose from scratch? We don't. We have some people will say that we do. And actually, there's a research group in England that's found ways that RNA can be produced abiotically. And they found a nice way that can happen. The problem is that it's really hard to imagine a natural environment that would have produced RNA at the level needed, at the concentrations needed, in order to give rise to the RNA world, using the models that have been found so far, the methods that have been found so far that RNAs are produced naturally. So this is the big mystery in the RNA world, is how did the first RNA chains come about? How did the first RNA nucleotides come about? And then how did they form chains? And then what exactly was required for those chains to replicate? So there's a lot of mystery still in the RNA world hypothesis. And a lot of this seems to be, I would say the most promising research on this is in the metabolism first view. And I'll be doing some videos for Stated Clearly about the metabolism first view. Essentially what this is that very simple molecules, very simple, very common molecules can form these cyclical reactions that end up spitting out much more complex molecules as byproducts of their own behavior. And these are cyclical catalytic reactions that happen. And we know that they happen in natural environments all the time. And we're actually starting to study these. And these things can evolve in a way that's slightly different than Darwinian evolution. They evolve kind of in the way that an ecosystem evolves, where there's not actually descent with modification that's happening. There's kind of a growth and change that's happening. So it's a really interesting field of research, the metabolism first view of the origin of life. And I'll put it in a paper. I'll link to a paper about that, or an article about that that's really good that I found too. It gives you kind of an overview of that. But it is looking like RNA either emerged from a simpler molecule that was similar to RNA, or it emerged as the byproduct of some sort of primitive early metabolic system. So all right, any more questions on that? It looks like no. We've kind of covered the questions on that. So just to summarize, I feel like I've been a little bit discombobulated in my thinking here today, or in how I've been saying things. But the reason that that creationist claim is false about the proteins is that they have built a straw man theory for how proteins emerged. They're ignoring the RNA world hypothesis. They're ignoring all the discoveries that we've made about how molecules can be naturally sorted by chirality. They're ignoring all of these different discoveries, and they're running math that really does work. The math really does work, but the story problem is wrong. They're misapplying that math. They're applying it to a straw man version of life origins chemistry. So now let's look at the second question here. Let me share my screen again. Share. All right. Scrolling. Okay. Here we go. So this is from an article. They called it a paper. It was an article by Jerry Bergman, and I've got the article here. It's The Evolution of Feathers, a Major Problem for Darwinism by Jerry Bergman. And I guess this is considered a scientific paper by the creationists, because he keeps referring to it. He keeps referring to it as a paper. Normally that means it's a peer-reviewed type thing. In his paper, he says that there are 9,000 living species of birds that are now known, all of which have a very unique skeletal morphology, yet only 45 extinct bird taxa have ever been identified. So what he's saying is that there's 9,000 birds today, only 45 extinct bird taxa that have been identified. Sorry, 9,000 species of bird. That number is actually currently wrong. There's over 10,000 species of bird that we now have named. But I think when he was writing this, that was probably accurate. He goes on to say, this is strong evidence that relatively few types of non-modern birds have existed throughout history. So he's saying that the fact that there's only 45 extinct species we know of means that there just weren't very many species beyond what we see today. This conclusion is supported by the fact that of 329 living families of terrestrial vertebrates, fully 79% have been found as fossils, as have 97.7% of the 43 living terrestrial vertebrate orders. So what he's making it sound like is that because we have 97% of all orders are found in the fossil record, that means that, all of the species that exist must have been discovered in the fossil record. All the species that ever existed must have already been found. He's using this number 97%. If you don't know how phylogeny works and you read this, the interpretation that you will get is that 97% of all species that ever lived on Earth have been discovered already in the fossil record. Therefore, any gaps that we see in the fossil record represent true gaps. They represent not just, the fossil record is impartial, but they represent that life fits into these nice, neat categories that we see today in living organisms. So, birds are the only animals that have feathers, for example. And so we don't see birds that are transitioning from non-feathers to feathers in modern animals today. And if you believe what this guy is suggesting, that 97% of all organisms have already been discovered, well, you're going to believe that that there is no transition of feathers in the fossil record, and you're going to believe that without looking. You think about these numbers and you just accept that. Well, what he's doing, the mathematical trick that he's doing, and a lot of creationists do this too. Here's a family tree that I drew really fast. Pardon my sloppiness here. And here we see species, genus, family, order, class, phylum, kingdom, domain, and then life. And so this is how life is structured throughout evolutionary history. By the way, these are upside down. My tree is going in the opposite order as the graphic on the left. Again, I didn't have time to fix this morning. I apologize. But if we color code my tree here, we see that on the top, this color represents the species color down here. We see that on the top, there are 18 species represented in this tree. We see that there are, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9 families, or sorry, 9 genus in orange here. There are 4 families in yellow, and there are 3 orders in green. So what paleontologists tell us is that fossilization is extremely rare. So when we find gaps in the fossil record, the reason for this is that most organisms that have lived on Earth and then died, they don't become fossils. And we actually know this by actually observing animals die and whether or not they become fossils. when I was a kid, I used to walk around. I used to have to walk really far to the bus stop and to the park that I always used to like to go to after school. And I was fascinated in watching roadkill. It was this long country road I'd walk down. And so there's always something dead on the side of the road. And I like to watch roadkill rot because I don't know, I'm weird, I guess. But what I notice is that it only takes a couple of weeks for something to completely disappear. Even the bones will disintegrate. They'll be eaten by bacteria, and they'll get messed up in the sun. Other animals will take them and scatter them. And so when I started learning about fossils, it made perfect sense to me that most organisms that die don't turn into fossils, because most organisms that die get torn apart. They get torn to pieces in weeks. And so if that's true, and we know that it's true empirically, we observe it true, that most things that die are not fossilized. If that's true, and then if you consider the fact that most things that do fossilize never get discovered by scientists, it's very rare for an organism to be found as a fossil. So here I've got 3 organisms that I'm going to say fossilized in my, 18 possible species here. Well, if we look at the math, if just 3 out of 18 species fossilize, that's only 17%. But look at the genre, how many, the genus of animals. Well, that's 3 out of 9 are represented in the fossil record, you see, because there's 9 genre and 3 of them are accounted for. And then for families, we have 3 out of 4 families are accounted for, even though we only found 3 individuals that fossilized. And for orders, that's 100%. 100% of the orders are represented here in this graph. And so you see that when he makes this statement, 9,000 living species of birds are known, all of which have a very unique skeletal morphology, yet only 45 extinct bird taxa have ever been identified. In the fossil record, we identify things by genus only. We don't identify things by species. So he's making a jump from species to genus here without really telling his audience that that's what he's doing. Then he makes a jump again. This is strong evidence that relatively few types of non-modern birds have existed throughout history. This conclusion is supported by the fact that of 329 living families of terrestrial vertebrates, fully 79% have been found as fossils. Again, that 79% is just an artifact of math working on a family tree. He jumped from species to families. So he's saying that, we only 45 out of 9,000 species, but now 79% of families are accounted for, and 97% of living terrestrial orders are accounted for. And so he's using a very sneaky math trick to make it seem like the fossil record is complete, when actually the fossil record is not at all complete. Very, very few things fossilize. That said, throughout history, our history of studying fossils, we have found gaps filling essentially every single major transition. The transitions of animals that you would be familiar with, so land animals, the only transitions that we really don't have are the transitions of bats and their pre-flighted ancestors. So we don't have a nice transition showing the evolution of flight in bats. We do have a really nice transition now of showing the evolution of flight in birds and the evolution of feathers, which, funny enough, is what this article is about. He's ignoring all of the fossil evidence that we have showing both of those things. The other transition that we don't have solid is the transition of turtles. So from completely non-shelled organisms to shelled organisms. It's, in particular, the transition of the shoulder blades going inside the rib cage. That is not well understood by the fossil record, and the evolution of bats is not well understood from the fossil record. All the other transitions, the transition from fish to land animal, the transition from reptile-like early organisms to modern mammals, that transition is very, very clearly shown. The transition of whales from land animals, the transition of birds from theropod dinosaurs, the transition of you name it. Like, we've figured all of this stuff out. We've found fossils that show it. Even though the fossil record is so scarce, we've been able to find all of these transitions. It's absolutely spectacular what we've discovered studying the fossil record. So those are ways in which, two ways in which creationists are using math to lie. Again, this is a super common trait in all arguments. People arguing anything complex will select specific sets of numbers and use little math tricks to deceive each other. Sometimes they do this on purpose. Sometimes they do it on accident because they suck at story problems. I think that maybe that last example where he's using these numbers to say that the fossil record is complete, I think that might be him actually getting confused when trying to do a story problem, like a genuine him not knowing how math works in context of the larger picture here. Maybe he was actually being deliberately deceitful. I don't know. In the case of William Dembski, to say that he's not deliberately lying there is really tricky because, again, he has to ignore paper after paper after paper after paper in order to make the claim that he's making. So it's, I mean, I guess the same is true for the fossil record stuff, but yeah, that's it. That's how we lie with numbers. We screw up on story problems and we cherry pick our data sets. That's how we do it. That's how creationists do it. That's how politicians do it. That's how scientists do it on accident or on purpose. It's something that we all need to watch out for very carefully. Math, it gives us a false set of confidence in our conclusions because math can't be questioned, right? So, all right, I'm going to go back to questions here, see if anybody's got any stuff for me. Shelled Reptile says the fish to tetrapod transition is not clear. They found trace fossils long before Tiktaalik and one of its ancestors. So something important to note when we're looking at transitional fossils, and I've talked about this. I'm trying to think of the video that I did that talks about this specifically. I think it's either number 3 or 4 in my talk, in my video on the Ark encounter. I think it's video number 2 or 3. I talk specifically about Tiktaalik. Tiktaalik is a really nice, fully formed fossil showing a transitional species between a fully aquatic animal and a fully terrestrial animal. Tiktaalik is an animal that could go on land and could go in the water and would be pretty much equally comfortable in both. Before Tiktaalik, we don't have full fossils of such organisms. But we do have lots of trace fossils of them. So we know that they existed before Tiktaalik. But Tiktaalik is a really nice example of one that was capable of doing that. And we don't know, when we find an organism like Tiktaalik, if you look at the evolutionary trees that biologists build with these, you'll see that there's a branch that goes up to Tiktaalik, and then another branch, you go down to a node, and then up to modern tetrapods from that. The reason that we draw our evolutionary trees like that is that we cannot assume that Tiktaalik is actually the species that gave rise to all modern tetrapods. In fact, it was most likely the case that an ancestor of Tiktaalik had 2 children. One ended up giving rise to Tiktaalik, and the other gave rise to modern tetrapods as we know them today. It's actually very unlikely that Tiktaalik itself, that species itself, gave rise to modern tetrapods. And that's just because of probabilities, which I go into in that video. I believe it's video number 2. So does that make sense? Or did I just ramble incoherently there, Shelled Reptile? when we have these transitional fossils, these series of transitions, we're not actually saying that this animal morphed into this. We're saying that there was a common ancestor that gave rise to this, and then there's a common ancestor later on that gave rise to this, and so on and so forth. We can't actually say that Basilosaurus gave rise to modern dolphins, right? Most likely it was an ancestor of Basilosaurus that gave rise to modern dolphins. Ration Allmine says trace fossils predate fossil transitional tetrapods for environmental reasons. Yeah, it's way easier to preserve a footprint than it is to preserve an entire animal. And yes, they're stating that the paper that talks about the footprints in Poland that show that tetrapods existed before Tiktaalik, that paper itself has a modified phylogeny in it. And the other important thing to know about fossils is that a lot of people assume that the moment we find a fossil in the fossil record must be the moment that species emerged. And that's, of course, a silly idea, right? So people will look at Tiktaalik, they'll date the rocks that Tiktaalik was found in, and then they'll assume that, oh, this year, I can't remember what date, it's like 300 million years ago or something. Don't quote me on that. I can't remember when Tiktaalik, what date Tiktaalik has on them. But people will say that, oh, that is the time period that tetrapods emerged. Well, because fossilization is such a rare event, we don't see species as they emerge. We see them as they become dominant in an environment. If your species has already dominated an environment, there's millions of you that exist, the rare chance of becoming a fossil becomes greater for you, right? Because there's millions of you. So even something that happens, it's 1 in a million chance. If there's 10 million of you, well, you got there's a 1 in 10 chance that a member from that species will become a fossil. So the fossil record doesn't show us what species exist at any given time. It shows us which species are super common at any given time. The only rare exception for this is in a Lagerstätten, which will fossilize, some sort of natural catastrophe will bury everything in one particular ecosystem right away. And in those cases, you can actually see pretty much all the organisms that were alive in that little region that got buried in this catastrophe. So there are exceptions to this, but in general, the fossil record only shows us the most common organisms at a given time, which means that their actual evolution, their first emergence happened much earlier than what the fossil record shows us. James says, stated clearly, we now have a dinosaur called Thanos. That is awesome. I did not know that. Yeah, Shannon's reminding everyone, make sure to put @stated clearly in your comment so that I can tell that it's an actual question rather than just random comments, because there's a lot of people today chatting. I think that does it for questions right now. Oh, someone says that the Audubon Society says that there are nearly 20,000 bird species now. So yeah, some of this is debatable. Are these two groups of birds a species? Should we qualify them as a species or not? There's a huge controversy going on in Oregon right now as to whether or not the spotted owl really is a species or if it's just a subpopulation of barred owls. But And the reason that's a huge debate is because the spotted owl is on the endangered species list, but it can mate happily with barred owls. So people are saying it shouldn't belong on the endangered species list because it's not really a species. Yeah, it's there's a lot of controversy around how to even count species, but yes, we are rapidly increasing the number of bird species that we know about for several reasons. One is which we're getting better at defining a species, or people have more agreement on how species are defined now than they used to, even though there's still a lot of argument. And then we have people love birding, so we're really good at identifying bird species. Someone just posted 375 million years ago is the date that we have for Tiktaalik. So thank you, Sebastian. All right, well, I think that sums up today's lesson. That was fun. It was fun. It was fun going through and finding how people are using math to confuse people, not only in the creationist literature, but also on Facebook. And it was funny how quickly I was able to find those two Facebook arguments. So, and we found that even top-notch researchers that spend their life studying statistics and analyzing data do the same. They screw up how to use numbers to come to conclusions. It's super easy to do. So I guess the moral of the story is when someone proves their point with math, they didn't actually prove their point with math. You need to be very careful and look at all of the reasoning behind the proof that they're providing. And particularly ask yourself, are these all of the variables that we need to consider? Are these variables legitimate variables to be using at all? And by answering those questions, you can come to see whether or not someone's mathematical argument really is legitimate or if it's garbage. And I'll tell you that the majority are garbage. One last example that I want to tell you that a friend of mine that teaches high school biology made. There was a study a while back by NIH that discovered that in the human body, there are roughly 10 times more bacteria than there are human cells. And my friend was teaching his students that you are mostly bacteria. He extrapolated from those numbers, 1 out of 10 cells is human, the rest are bacterial. Well, he was extrapolating that to say that you are mostly bacteria. Well, that is wrong because bacteria are tiny. Bacterial cells are tiny compared to human cells. And the actual mass of bacteria is about somewhere between 2 to 6 pounds in a 200-pound adult male. So between 2 and 6 pounds are bacteria, even though they outnumber our human cells by a dramatic number. So he came to this wrong conclusion and was teaching that to his students because it seemed to make sense given the numbers that he had been looking at. He failed to look at the other relevant numbers in that problem. And we do this all the time. I guarantee that I believe things that are false because of math problems. I guarantee that you believe things that are false because of math problems. It is super easy to do. So be careful, ladies and gentlemen, as you go forth in your studies of how the world works, because math can screw you up. So long for now. Stay curious.